Hi everyone, I'm back to tell you a little bit more about how to add stochasticity to a simple spreadsheet model. So, let's get started. When we left off, we had a basic logistic model. So the model has started off, population grows rapidly. When it's at small sizes, we get some environmental resistance, some other factors that push back against population growth. We approach carrying capacity, and it levels off. Here's the formula that we're working with, simple recursive formula that looks back at a previous population size to predict a future one. And here are the key parameters that we're working with. We're going to work with an initial population of 500 individuals. We're going to work with a population growth rate of 0.05 or 0.5, and we're going to look for a carrying capacity of 10,000 individuals. We're going to actually be messing with the population growth rate, and that's kind of the point of what we're doing here today. So more on that in a second. Let's move all that information off to the side of our screen, and then let's give this a shot. So here's our initial population right here. That's at time 0. Here's our growth rate. Let's set that to 5. Make sure that we're being consistent. It's going to get a little wonky for a minute. Let's make sure we check this formula against the way that we'd like it to be calculated. So B2 is our initial population. We're good there. And then we're going to have an absolute cell reference, D2. So it's always going to point to that cell no matter where we copy the formula. Multiplied against B2, which is going to follow us around. So that's our initial population. We're good there. And then we're going to multiply that going to multiply that by our density dependent factor, right? So that's our carrying capacity minus our current population size divided by our carrying capacity, which basically puts the brakes on. Here's what's going on, why our model's funky. The R is way too high. There we go. That's the R we were looking for. Okay, so what we would like is an average R. Maybe that R is on average 0.5, but it might range from, say, 0.3 to 0.7. So let's try that. In this case, I want that R to vary for each year in this population or each generation in the population. So we're going to change that, and we're going to reference, instead of E2, we are going to reference C2, and we're going to let that be a variable reference that follows us around the whole spreadsheet. That's going to mess up our population model, but not to worry. We're going to do a rand between, and let's see. I said between 30 and 70. So 30 semicolon 70. And that'll give us a random number between 30 and 70. This is why we did the little intentional accident earlier. That's not the number we want to use. So we need to take that and we'll divide that by 100. Oh, look, 0.6. That's a reasonable number. That's a reasonable intrinsic growth rate for us to work with. Now we're going to need to slide that down so that we're calculating a different R for every population size, for every population time in our model. So you could do these, you could copy these results, and then you could replicate those results, and you could essentially run your model multiple times and see how that affects how long it takes to get to carrying capacity. Or you could see how likely the population is to survive or to go extinct. And you could just recalculate those each time. One of the really useful features here is that you might want to take your population and then copy that, and you'll copy the values, because you don't want to copy just your formula, because it won't work. It won't reference the numbers that you're no longer, that when you copy your formula somewhere else on the spreadsheet, it won't necessarily reference those numbers. For example, if I copied cell B3 and we didn't take our initial population size over, that would no longer reference to B2. It would reference to an empty cell wherever I copied it to. So I'd encourage you to play around with things like that. And I hope that helped you think about stochasticity and how to stitch stochasticity into simple population models in spreadsheets. Have a great day. Thanks for listening.